All right, so let me give you the answer. You let me know if you don't understand something. Anybody know what happened to Leanne? Is she okay? Yeah. Because yesterday she was like keep on going walking. I know like her dad was trying to fly in from Saudi Arabia to United States, but they have missiles everywhere. So I don't know. She's okay. All right. Anyway, so
Oh, she had a doctor's appointment.
all right. So the first question here's let me know if you need to go over anything. Please let me know because I'd rather help you than you just nod. Please don't nod. If you don't understand, ask me questions. Okay. So first one, yes.
Can you go over H?
What?
Can you go over H?
H? Yeah, we'll go over one by one to make sure.
That was like, I can get that.
All right. So shh. The first one is a pi between 2 to 11, square root of x minus 2, parentheses, square dx. Is this okay? Anything I need to go over on this one? Yes? Oh, well, we get there. We get one at a time. So b is going to be 0 to 3, 11 squared minus y squared plus 2, parentheses square dx, pi in the front. Good? That's dy, right?
Something that confuses me is like, when is it going to be like the outer subtracting from the inner, and when is it going to be like the inner subtracting from the outer?
Okay, so are you talking about this particular question or no?
Like, okay, look at like D and E, for example.
Okay,
we can talk about that when we get to it.
Yeah. So do you understand b for now?
Yeah, I understand B.
Okay, C is going to be pi from 0 to 3, parentheses 11 minus parentheses y squared plus 2, parentheses square dy. And this one's a disk. This one's a disk. And not only is this, it's this distance right here. But the problem, how do I get that distance? Is had to take the 11 minus the function, because the red part is not a green part. A lot of people probably think about its integration from 0 to 3 of just y squared plus 2, but it's not. It's actually 11 minus parentheses y squared minus 2, because you wanted to get the red part. And the green part is the function, so you have to subtract away from the function. Yes?
The function part is always from the actual y-axis.
Yeah, so that's why we write down yesterday. It says the f of x is the distance from x-axis to the function, and f of y is the distance from the y-axis to the function. Is that okay? Okay, you say D, right? D is this way. The reason why D is this one is from here to here. This is just, this is 3. And this has to be dx. It has to be 2 to 11. That's not a big issue. And 3 is not a big issue. It's the 3 minus root x minus 2. The reason being is, like this small part here, this is a function. Square root of x minus 2 is a function.
Yeah.
But we're trying to get a red part. We're not trying to get a brown part. So the only way to do it is take the black part, which will take this part here, which is 3, minus this to get this part right here.
Okay.
So that's why it's 3 minus root x minus 2. Because we want to get a small distance from the red line. The function is just the brown line, which is, that's not what we want. We want a red line. So the way you draw is I have to be very, very cautious.
Okay.
Is that okay? And that's E. E is this way. So I don't know if you got E. E just 2 plus that, because you got pretty much 2 distance. There's one here and one here. So it's 2 plus the thing. So that's going to be the outer function. Inner function is going to be 2, which is the whole. Are we okay here before we move on?
Why is it 2 plus that and then minus 2? Where?
Yeah, so that's a good question. So first thing is, oh. Okay, first thing is the outer functions from here to here, right? So this you can break to two segments, 1 and 2. This is 2, this is the function, right? This is the function. So it'll be 2 plus a function. That's how you get 2 plus a function for the outer. For the inner is this part, is from here to here, which is just 2. So you had to subtract 2 squared.
The outer is like to the top of the,
Yes, to the all the way to the end of the boundary.
and then the inner's to the x-axis.
The hole, yes.
Okay.
Because that's a hole you're gonna carve out. So this like look like it's a bullet, but it's a hollow bullet. Alright, yeah, if that makes sense.
Yeah, that's it.
Okay, for the next one, I think it's F. Is everybody have problem with? It's F. Hannah, you asking F?
No, that's shame.
Okay, but F is gonna be from 0 to 3, 13 minus y squared plus 2 parentheses square minus 2 square. Yes. That's a good question. Okay, so 13 is right here. Because they say rotation is 13, so I'm gonna redraw it. So this is 13 like this. So this is to 11, right? 13 is all the way here. And this is the rotation from this the outer radius and this the inner radius. Okay? So how do I get 13? 13 is the black minus the green to get the outer red. So the whole thing is 13 minus the green to get the outer red. So therefore it's 13 minus y squared plus 2 parentheses. Make sure you have parentheses so you can distribute that one, and square minus 2 square. So the answer is going to be like right here. It's not 11, it's 13 because it's all the way to 13. Now somebody asked, I think one period they asked a good question. It's like, how do I know stop at 3? What happened if you go in more? If you go in more, it's gonna have like this situation. Then this part is gonna be off. So you have to stop at 3 rather than go to 13. Or go to the next value. Okay. G is gonna be this. Do you guys got G?
You were hating, but I got it right.
What?
You were hating, but I got it right.
You got it right? Okay. I'm sorry. The last one is everybody have problems. H. It's a 14 square, which is from all the way from the left side. Is 3 more, and then 3 plus the function, which is that's the inner radius. The outer radius is 3 plus 11, so it's gonna be 14. And this is how I get the right answer here. Daniel, you need help with this one?
Yeah. I got all the others right.
I think 4 plus 3 plus 2 plus plus.
I'm gonna get 6 on the H.
Yes.
Can you not just write
What?
for H? Can you write 5 plus 5?
And it's
You wrote 3 plus
Yeah, you can write 5 plus y squared. I just added 2 segments so people can tell it's this segment plus this segment. Yes, Hannah.
So why is 14? Why is not 2 plus 3?
It's a 14 because you rotate all the way here. And this is 3 plus this. So 3 plus all the way to the end of the vertical line. So that's why it's 14.
The distance from X to the function.
What?
That let's say the distance from X to the function. That is we have to in the
plus 5 perfect.
I cannot hear you. Somebody let Hannah talk because you guys, if you speak, I cannot hear Hannah talk.
I think yesterday we wrote in number 6 the distance from X to the function. So I thought we need to take the distance from this vertical line to the origin.
Not to origin, it's to the all the way to the axis rotation. Because remember, that's why you draw from your axis rotation to the end of the graph. So that's why it's 14. because that's the part that's rotating. Because you shifted your axis rotation instead of y-axis all the way back 3 more units. So you need to add 3 more units on top of 11. From? All right, so this next question. Now I didn't do the work. I just do the setup because right now I only pay attention to setup. I don't have enough time to do the evaluation. But yeah, you should be able to evaluate this by hand. If you comes down push and shove, that you had to be able to evaluate simple integrals. The funny thing is, I was tutoring other school, and other school I heard is really bad. Like they don't even like I tutored this kid that doesn't even know how to take integration of square root y. And I just feel really sad, but hopefully that's not one of my students. Like you gotta be able to do the simple integral, and you have to be able to subtract one thing to the other thing. So, but this is a setup anyway. So how do I set up? I set two equations equal to each other. I find the intersection, -2 and +2. How do I know which graph on the top, which one on the bottom? I know which one's on the top, which one's on the bottom. I don't need necessarily to graph it. I can plug in 0 because I know between -2 and 2, I just plug in 0. I can know which one's on the top. So in this case, it's -x squared is on the top, and x squared minus a is on the bottom.
Mean 0 instead of 2 and -2?
No, you want to see out the area between the curve is top minus bottom, right?
Yeah.
You got to figure out what's on the top. So you can plug in between -2 to 2 into the function. So for example, I plug in 0 for -x squared, I got 0.
So if it was from 1 to 3, I'd plug in 2.
Yes.
Okay.
And you see which one's on the top. So in this case, you can judge which function need to be on the top.
One's on top. If it's set up so that they're one equation.
Because this is top minus bottom, so in this case, like just say for example, like I plug in 0 here, which is gonna be 0, right? So that's why this one's on the top part of the graph.
Oh, so I plug them in before.
Yeah, plug in before you do this part.
Okay.
So you plug in 0, you say, oh, this is on the bottom, so it's top minus bottom. Now this one is a little bit hardest one. This one is like Y perspective. Usually AP exam doesn't ask you area on a Y perspective. I do just because I think kids need to understand the other perspective, but you not necessary. So if any question, this question may be the question that you say, oh, I don't have to know how to do it. But here I go ahead and solve for x. So here I solve for x equal to 4 minus y squared. And I solve for x here is also is going to be -2y plus 1. And I set those two equal to each other. So you see I set those two equal to each other as a -3 and 1. Now, I know that I want to test just like what Jacob just asking. Jacob just asking, so now -3 to 1, so what's the number to plug in? Still 0 will be easy, right? Even though it's changed, but 0 is still easiest value to plug in. So if I plug in 0 here, it's going to give you 4. If I plug in 6, it's 1.
Pardon the interruption. Teachers, please check your email for an updated list of students that still need to take their PMAs. Thank you.
Okay. Okay, so, and this one's the top minus bottom, but you got to make sure you have parentheses. I'm going to talk about how valuable the parentheses. If you don't have parentheses, it's the wrong answer. Okay, if you don't have parentheses, it's the wrong answer. So that's that. Now here's the last 3. I don't know how you guys did, but this is the actual FRQ. The actual FRQ is a lot easier than my test. This is it. But you have to find those 3 intersections. Do you see that? I use the decimals to find out 3 intersections: 1.970, 5.242, 7.114. I plug it in, and I find out the R region is between 1.970 to 5.242. This is actual AP exam questions, FRQ. That's worth 9 points. The work is like so easy. The only one that's hard is C, because that's off-axis rotation. So I don't know if anybody got that one. It's 3 minus natural log of x, and it's 3 minus cosine square of x. That one's kind of hard. So that's why most of the students can get 3 points to 6 points, but the last point, the 9 point, is really like if you can get a 5. Any question about this part? It's okay?
Should be okay.
All right, so I'm gonna talk about cross section, which is I want you to, it doesn't really have to write a lot of notes down, but this is a cross section, which is the last part of the test. How do I do cross sections? Starting by, do you guys understand what is cross section? So a cross section's volume. Okay, cross section volume is actually interesting. It's not rotation. So you have to make sure it's not rotation. It's nothing to do with rotation. Okay, Samuel, pay attention. It's not rotation. So you're not revolving to the y-axis or x-axis, but the question will literally worded like this. The volume of solid resultant area generally occurs by y equal to square root x minus 2 and y equal to x equal to 11 and x-axis. Has a cross-section perpendicular to x-axis square. So what does that mean? They'll say perpendicular to the x-axis are square. So that means each slice is going to be a square. So you probably have no idea what I'm just saying, but the best way is to show you the visual. So usually you have cross-section, basic shape is going to be a square. Equilateral triangle. And the last one is going to be a semicircle. And last one's going to be a rectangle. Okay, so the cross section. So the only function I'm going to want to show you today is y equal to x squared and y equal to square root x. And I'm going to use a different color to justify that, so that way you can see it. So if I have a function like this, is that okay? And the red line is like this, is that okay? Am I going too fast? No, what is top minus bottom? What is top minus bottom here? The top minus bottom is this distance, right? Would you say? And we're going to call it S. Is that okay? Now, I'm going to say, I'm not rotating. I'm going to put this slice of S, I'm going to decide which kind of shape is it. I'm going to say, I want it to be a square. Now, it's very hard to visualize the shape. Very difficult to visualize the shapes. So I'm going to help you. This is the line that we just drew. Is that okay? Do you see that? It's a flat, right? Do you see that? It's not it's 2D right now. Now I say square, and you're probably not gonna see anything. Do you see anything different? I click the square. Do you see anything different? No. So we're gonna stand up this graph straight up. And then I'm gonna build a square from all the way here to small square to the biggest square to the biggest square right here to the small square right here. And I'm gonna add up all the squares. Now the square is based on what? Based on the difference between two graphs, right? The S. Right? Because the S I here is big, and I here is small. I here is big, I here is small. Lee, are you paying attention? Okay, so it's different sizes because depending on the distance between two graphs. Is that okay? So then I'm gonna build it to infinite amount of pieces. And this is this shape. It's pretty cool, right? So we are gonna find a value in this shape. So how do I find a value in these shapes? Yeah, it has to be with integral, right? It has to be with integral. It would be integral of all the square add together. There's infinite amount of square here. Now this one's not rotation, it's not revolving, so it's not a disk or washer, but this time it's a square, but it's not revolving. Are you guys understanding?
Yeah.
Okay. So then you're gonna say that's fine. So how would I set up the integration for this one, for square? Well, square is gonna be, some people say it's integration. What else I should have? There's no pi because there's no rotations. The what? Okay, let's do a bound. In this case, it's gonna be from 0 to 1. But we're gonna say A to B. What else? We have S. So what do you think the square is going to be? That's it. Why? Because this is 1s, right? If I times s by s, that's what I get, square. And that's dx, right? And that's it. That's integration of s squared dx. The s is top minus bottom. That's it. It's very easy. It's one of the most common question. And the most common question that's actually just asked is square. That's the most common one. You see like 3 out of 6 exams is going to be asking you to square. Now, sometimes they do ask other shapes, like equilateral, triangle, semicircle, and rectangle. But we got to look at the shape first. Yes?
So in the s square, it will be square root of x minus s squared, and it will be square.
Yes. Does that make sense? It's not hard, right? Top minus bottom. Now, if today it's equilateral triangle, it's going to be a to b of s squared dx square root 3 over 4. Now, you're going to say, how do I get square root 3 over 4? Yeah, that's a little bit harder, so we can go back to explain that in a second. And so you have to know that this is a coefficient you have to remember, square root 3 over 4. The next one is from a to b of s squared dx and a semicircle. Wait, what's semicircle? Here it's going to be pi over 8. Rectangle is a little bit harder, but we don't have time. We'll do that maybe after the break. I don't know how much time we have. But we're going to explain to you why is square root 3 over 4 and why is pi over 8. That's kind of complex, but we will try to explain to you. But the calculation is not hard. So let's go back to here. But I want to show you the shape. Like, what can you tell? Like, this shape looks like, I don't know. I never seen this shape before in my life. Slice of a pear. Huh? A Pringle stack. I can see that, but a Pringle stack have uniform shapes, though.
Looks like a bike seat.
Okay. Looks like a what?
Bike seat.
A bike seat? I don't know about that.
No, that's not a bike seat.
I know that there were some shapes looks like this. I think like look kind of like, I don't know. Have you seen picture of Sydney Opera House?
Yeah.
The architecture of Sydney Opera House. I feel like it's kind of like that, but I could be wrong. I heard that there is a lot of mathematical architecture, and Sydney Opera House is one of the mathematical things. You can look it up, like how much math is involved with that structure. It's pretty fancy. Okay, so now you're gonna say, well, what's the difference between square and equilateral triangle? Look at the shapes, right? Does that look different? It's smaller, yeah. So square root 3 over 4 is smaller. And you look at here, right? It's kind of look like a mountain range of the mountain, like, right? Like, I don't know, some type of mountain formation. And this look like a slug Some people told me like let's look like a slug.
Or like a basic drawing of fish.
Huh?
Like the
Oh, half a fish.
yeah, like a really basic drawing of one.
Yeah, but it's a half a fish cut in like a cross section like this. Okay, so yeah, this could be a half fish. Now you say, okay, well, why do it's a square root 3/4 and why is pi over 8? There's a reason for that. But for AP exam purpose, just memorize it. Now I'm gonna explain to you why it's square root 3/4. Because equilateral triangle is like this. It's 60 degrees, 60 degrees, 60 degrees, right? And if you have a very good geometry teacher, they actually tell you it's square root 3/4. Now, this whole thing is the S, right? Which is we put in red. This is S. Is that okay? This is going to be S divided by 2. Is that okay? Now, remember the 30, 60 degrees. So this is 90, this is 60, this is 30, this is X, this is X square root 3, this is 2X. Now, if this is shorter side, this is 30 degrees. 30 degrees facing the X, which is facing the S over 2 here. So that makes this side, it's going to be S over 2 times square root 3. Now, remember, area of a triangle is what? It's 1/2 base times height, right? So 1/2, the base is S, right? The height is square root of 3 over 2S. So if I multiply together, I'm going to get S squared square root 3/4. Does that make sense? So that's where they come in. This is geometry basic formula. When I taught geometry, all my student knows this one. But, I mean, now geometry teacher, I have, like, there was a kid want to join a math competition, and I asked him, I said, oh, what's the area of a circle? And he's like, I don't know. I think that's what the bad is. Like the geometry teacher doesn't. You didn't even emphasize on the area of circle. And the kid is great. I love the kid. Very studious. Come to lunch, try to get better. But I think that geometry teacher is not doing a good job.